the help of my supervisors, the topic was recently transformed into towards agricultural transformation, trends in gender work patterns, perceptions, and adoption of soil and water conservation practices in Rwanda. I'll cover, I'm going to present from the study context all the way to conclusion and policy implications. As an introduction, in developing economies, agriculture is rapidly transforming due to land degradation, changes in land uses, crop patterns, and gender dynamics. Some consequences of degradation include varies from reduced food production to poor water storage, and also degradation leads to decline in the land economic value and transformation of land use types, loss of biodiversity, soil organic carbon, and ecosystems. So over time, the process of degradation has been influenced by some socioeconomic dynamics and also been aggravated by climate change issues. So then transforming gender relations can reduce the rate of land degradation and improve agricultural outcomes. Some of those dynamics of transforming gender relations can mention the gender work patterns, perception, and adoption of soil and water conservation practices. However, there is limited research on trends in these gender differences in work patterns, perception, and adoption, and the relationship to agricultural transformation process among smallholders. So with many studies, these are abundant studies that are focused on the effects of gender, the socioeconomic factors on soil and water conservation, to reduce gaps in productivity, but the link between gender differences in soil and water conservation, taking account of those aspects, has not been clear, especially in northern Rwanda. Therefore, the objective of this paper is to contribute to the understanding of gender differences in soil and water conservation practices by focusing on trends in gender work, adoption, perception, governing roles, power position, and managerial practices in relation to agricultural transformation. This is my study area. We are focusing on Rwanda, the northern province of Rwanda, especially the three districts, Burera, Kenya, and Musanze. And then these districts have high concentration of farming activities, mainly for agricultural, non-traditional agricultural export crops. And then some animal husbandry practices are very developed in this area. And there, however, the area also has a high decline per capita availability of agricultural land per household due to, and has also very low small farm sizes. The research design, we used a multi-stage sampling procedure, whereby in stage one, we had a purposive sampling of district. In northern province, we chose three districts, Burera, Musanze, and Gakenke, due to these reasons mentioned. And then the second stage, we had a selection of 5 sectors, 2 sectors in the 2 districts, and 1 sector in Gakenke. And then we had a probability proportion to size when selecting cells. Those are administrative units, and then also we had a random selection of villages, whereby you had 19 villages. And then you had a simple random sampling of 442 households. For the sampling techniques or methods we use, this study, as we said, we used a mixed method, whereby we used quantitative method, mainly the participatory rural appraisal, the GIS mapping to map the land uses over time, and then the quantitative survey by conducting a household survey of 442 households. For these participatory rural appraisal techniques, we use transactive work with 12 participants, 3 from each sector, each administrative sector. We use gender resource mappings, where we had 8 sessions, 4 for male and 4 for females, and then these were complemented by focus group discussions and key informants interviews. As we said, we use also GIS mapping to map the land uses over time and see the changes in land uses over a period of every 10 years, starting from 1970. And then we conducted a household survey on 442 households, taking into account male and female, and in total we had 653 male and female respondents. For our results, we first had results of gender and socioeconomic characteristics of households. And as the table is showing, we saw that there is gender differences in different socioeconomic characteristics, including age, education, and of farm occupation, which were statistically significant at 1% level of significance. And also, there was gender differences in access to services, including input markets, product markets, and access to farm plots. Again, we saw that there is high proportion of women has been participating in agricultural activities, including food crop farming, cash crop farming, livestock raising, and soil and water conservation investment. However, male had high proportion in non-farm economic activities and wage and salary employment. So our quantitative results were complemented by qualitative information from focus group discussions and key informants interview, whereby in the FGDs, participants mentioned that norms and culture still play a role in explaining these gender differences in farming activities. For example, for staple crops that are meant for household consumption, we find that more women are more responsible for farming activities, and women are mostly involved in household chores. And then when men are involved in farming activities that are for value cash crops, mainly Irish potatoes. Also, from the information of a 42-year key informant local leader, he agreed that men have greater participation in commercial activities and of farm business than female. Results also, using GIS mapping, we tried to find the trends in land use patterns and the effects on soil and water conservation investment. Then from before to 1990 to 2020, we saw that there has been the interaction between policy changes, economic transformation, population growth has made, and redistribution had implication on the viability of land use system and increasing small farm sizes. Then, for instance, the commercialization of agriculture has led to intensification of land uses. And then this has led to the changes in the different land cover types, whereby from that period, the forest land has declined from 50% to 44%, whereby grassland has declined from 14% to 10%. Then of recent, it has also increased to 17% due to some policies that are being put in place to increase crop cover. Then cropland and settlement has been increased since that period, 2010, due to those transformation processes that has been taking place. We used also gender resource mapping to different groups of male and female to map out the gender differences in participation in soil and water conservation and how this had implication in different policies on these activities. As you can see in this figure, between 1970 and 1990, there was more men participation than women in fighting the effects of climate change and soil erosion. And then also this also in the same period, a big number of men and women in 1980 to 1990s, more men were participating in forest plantation and the other different erosion control activities than men. So then from 1994 to 2000, there was concentration on taking care of destroyed forests during genocide. This was marked by involvement of both male and female. And then there were new policies from 2000 and on intervention that were advocating for gender mainstreaming in every activities, including soil and water conservation. And now, in this period from 2000 to 2005 and up to current period, we are seeing the agricultural transformation process taking place, and this it requires the equal gender participation, task allocation, decision making. But however, while men are found in financial investment related activities, mainly high productive crops and of farm businesses, women's time is still limited by high involvement in farming activities and household and core unpaid activities. Also, we have the results on gender decision making, whereby we ranked the decisions of male and female within the households. And we found that a big number of female, as we have seen before, were more involved in, had some to most decisions in food production, cash crop production, and then livestock raising. And then around 67% and 74.4% are male who are mostly involved in decision making regarding non-farm businesses and wage and salaries. So when we conducted the focus group discussions, we were informed that generally men collaborated with their wives in making land and household decisions. However, the issue of cultural beliefs remain a limiting factor for the joint decision-making process and agricultural development. So there is also an uneven distribution of decisions regarding household investment and the asset acquisition. And for example, you can find some cases where a man can rent out a land without the consent of the wife. Also, we had information agriculture get a perception and adoption of the communities about soil degradation and soil conservation.
You have 2 minutes, Mr. Ferry. Okay. 2 minutes to
and then experts indicated that the erosion is very high as shown in this image, and then also they are trying to use their efforts, their personal efforts to to restore the land which has been eroded by the erosion from the Volcanoes National Park. And then this information perception has shown that relatively both women and men, they are aware that adoption is the very low of different soil conservation practices and soil fertility management practices. So as a conclusion, this study used the mixed methods and including quantitative and quantitative to assess trends in gender work patterns, and the results indicate that there is gender differences in socioeconomic characteristics and access to factors, market access factors. This also implied that women should receive specific intervention to increase their roles and participation in agricultural production. So the level of perception is high, but the adoption rate is very low, which means that there is a lack of farmers' capacity to adopt the practices or less involvement of extension agents in resource conservation. The results also indicate that the role of women and their duties related to management regarding food and cash crops is increasing. So which informs that there is a feminization of natural resources use And this can create women's massive response to employment opportunities in agricultural commercialization. Yeah, thank you very much. That was my presentation.
Thank you so much, Sabili, for this very interesting study. Perhaps a quick one for you to reflect on as we allow the audience to be able to raise questions. We might probably allow you to answer one or two questions. Some of the questions can be written on the chat so that they can be responded to later on. Now, what do you think is the main explanation for the apparent shift in segregation of division of labor in terms of farm production and other related businesses?
Yeah, one way we are finding, despite having the good policies that are advocating for gender equality and equity in all activities, even including these agricultural activities, one of the major things that is still giving these segregation differences is the cultural based or beliefs, whereby mostly men, even women, they are still considering their traditional way of living or practicing things, and then they are reluctant to get out of that.
Yeah, thank you very much. Any other feedbacks for our presenter, Mr. Philly? You can indicate using a yellow hand. Yeah, I can see Dr. James Mushori. Please go ahead.
Thank you, Chair. My name is Dr. James Mushori, University of Nairobi, and lead expert in environment. Thank you for your presentation, the presenter. I just have a few comments regarding your methodology. You kept mentioning that you have used mixed methods, but in your submission, what was coming out was just quantitative and qualitative. If I may ask, how did you analyze quantitative data, and how did you analyze qualitative data? And then, if there was any sort of correlation in your study to show that there is the difference that we're talking about, the gender difference, how did you correlate that, if there was any sort of correlation? And then lastly, I've observed that the return rate or the sample that participated in your study is varying across from the table which you presented, which you had indicated gender decision-making results, gender differences in soil conservation. I see a sample of 633, 129, 512, 210. Why the variation? Thank you, Chair.
Thank you very much, Dr. If Musafiri, you can just respond in a few seconds
Okay,
to
thank
the
you very
issues
much
raised
for,
by Dr.
Yeah, for the question. When the question was about the quantitative and mixed method. Yeah, I call it mixed methods because I was using different techniques to triangulate the information. For example, I use quantitative methods to assess the socioeconomic characteristics, which are gender, age, gender, income, and others. And then I complemented this with the information from qualitative and maybe transactive work or resource mapping. And then also I use some GIS mapping also to get land users over time. And for the qualitative, we use resource gender resource mapping also to get information about gender differences in that. Mainly, these are different techniques I use to triangulate information, being the same information on one variable. That's why I called it mixed method. And then for the analysis, for the qualitative, I use thematic content analysis to analyze the qualitative information. And then for the quantitative, I use the mostly descriptive analysis, and then also the t-test to show the significant differences for certain variables. Then there's another question where it said gender differences and correlation. I didn't get the question. Let me first answer for the other question on sample. The sample which is varying. So for the qualitative analysis, I use different techniques. So if I was using like the transactive work, so it was like we are having a work for a catchment with some key people in the village or in the sector, administrative sector. So those are the number of people who were together during the transactive work. And for the focus group discussions, I was mentioning the sessions you have with the groups of either male and female. That's why I was giving a different number. But when it comes to quantity,
thank you, Musafiri. Our time is up. Our time is up,
okay,
Musafiri. We can engage on the platform. Eh? Thank you. Yeah, thank you so much. Thank you for that presentation.
Thank you.
Yeah, very good. Now, if you can stop sharing so that we can invite another presenter. Yeah, to share. Now, Gitonga, if you logged in, please. Gitonga is going to talk about ameliorative effects of natural products on serum biochemistry and histopathological changes of broilers fed aflatoxin contaminated feeds. So Gitonga, if you're already logged in, please, we would like you to go ahead and share your work with the audience. Musafiri, please stop sharing.
Oh, sorry.
Yeah, stop sharing. Yeah, stop sharing. Gitonga, can you hear us? Thank you. We can see participants from Ethiopia. You're most welcome. Pamela Gitonga, if you're ready, please go ahead and present your work. From DUPA, congratulations. Thank you. Now, it doesn't look like Gitonga is ready. Can we have GN Obwola? GN Obwola on characterization and the biochemical analysis of municipal solid waste to generate clean alternative biomass energy for improvement of livelihoods in informal settlement, Nairobi County. Obwola, please. If you're already logged in.
Thank you, Prof. I think it is Nyambati G. It's Nyambati G.
Oh, it's Nyambati G, eh?
Yes. Am I to use my slide or?
Yeah, please go ahead and use your slides. So
can I have the right to share?
Yeah, you can have the right to share. You have the right to share.
Just a minute.
Okay, then. So Grace Nyampati, please give us all your other details so that it is easier for us to be able to acknowledge this work. Huh? I hope somewhere on this chart, you'll be able to give us your relevant details.
Okay.
Okay. Again, Nyambati, please help us to save time, stick to 10 minutes presentation so that we can have 2 or 3 minutes to be able to discuss your work. Go ahead, Nyambati. Okay.
Thank you. Good afternoon, team. My name is, thank you, Grace Nyambati from, Dr. Grace Nyambati from Technical University of Kenya. I am presenting something on waste management, that's on municipal solid waste. It's a project which actually was supported by a number of stakeholders, because we have KILD, technical, we also have JKU, NRF, and also Egerton University. Thank you. So the title here is the characterization and biochemical analysis of municipal solid waste to generate clean alternative biomass energy for improvement of livelihood in informal settlement in Nairobi City. This was done in Nairobi City. You see, we are all from various affiliates, which I have not shown, but we are from the different institutions. Rapid population growth, industrialization, and growth of economies has led to generation of tremendous municipal waste and management problem, especially in cities in the world. Cities of developing countries dominate in sanitary landfill, contributing to over 59%. We have open dump site about 30%, and about 26% is actually thrown everywhere in the cities. The municipal solid waste is a byproduct of a broad spectrum in industrial materials, services, manufacturing processes, and they include chemical, metal, wood, paper, leather, textile, and other products. In Kenya, around 56% of urban population live in slums, which is usually characterized by inadequate provision of basic services, especially management of solid waste, municipal solid waste. So the proportion of solid waste generated to what is collected is very low. So much is generated, but collection becomes a challenge. So that's why you have it scattered within the informal sector. Waste to energy is a noble strategy because the utilization of waste reduces the amount of landfills while increasing renewable, affordable, clean, environmentally friendly energy in form of biomass. Sorry, my slide is gone. Excuse me, can you hear me? Can you hear me?
Yes, we can hear you.
Thank you.
We can hear you.
Thank you. Somebody sharing, I think, my slide somewhere. Okay, these are the objectives. I have a different slide, please. I have a different slide. And I can't control, please. Okay, move on. Move next. Next. Okay, fine. Here. Let's the one before this. Hello, the one before the slide above. Okay. We have objectives. Let's move ahead. Thank you. So we had quite a number of areas to look at. We have characterizing the types of solid municipal waste and conversion. We have determination of the method of conversion or the technique of processing the conversion, and also determination of the physical and the chemical content of the waste jar, which will be converted to biomass. And they include, we have moisture content, looking at the ash bulk content, the volatile matter, and calorific value. Next. Next, thank you. Yeah, this was done in Babadogo. Actually, these are some of the members of the team. Next. Very good. This is a site, the map, where, you know, Babadogo, the area is just in Ruaraka constituency in the city. And it's actually an area with quite some informal, a mixture of informal and formal sector. Next. Next, thank you. So the method is the municipal solid waste was collected, it was sorted into either combustible and non-combustible material. Then the combustible is the one that was dried, then transported to the engineering workshops in a technical university for processing. The samples were carbonized to produce char, which was used to make the biomass fuel. Then before that, this char was subjected to physical and biochemical analysis at Kiln laboratories. So the moisture content, the fraction size, pressing temperature, and are the most important parameters to manufacture, especially briquettes as biomass. Next. Thank you. So this is the flow, the separation, the sorting, characterization to the inorganic, nano-combustible, and also organic. Next. Then from there was carbonization, which was done of the organic dry material into char, which was then finally processed for biochemical and chemical analysis. And those are the parameters which were done: the moisture, the ash, the volatile, and the calorific value. Next. Thank you. So the proximate analysis was done in order to estimate the heating value of the biomass briquette, which was produced. Also, it was to determine the composition of the municipal solid waste in terms of the gross component, yeah? Because these are essential for quality characterization of the fuel material. In fact, they even determine also the ignition period. So that's why that characterized, the biochemical and the physical analysis was done. Next. Next slide, thank you. Yeah, no, this is just what was done. So the moisture content was determined. The samples were placed. This is the formula which was done, and it was done under for a sample was placed in an oven for moisture for 2 hours at a temperature of 105, and this is the formula for calculation. Next. Next, thank you. For the volatile matter, which is a key component of solid biomass fuel, because it's used to measure the combustion characteristics of the biomass fuel. So volatile matter, the dry material, was for releasing the vapor, vapor released when the fuel is heated. The volatile matter of each organic sample is actually that vapor which is released when the fuel is heated. Then this was determined by keeping in a temperature of 940 degrees for 10 minutes, then in a partially closed crucible in a muffle furnace. These are the instruments which were in the lab, which were used. Then there was also a formula used to calculate the volatile matter. Next. Yes, there was also determination of the ash content, because the ash content is also a measure of how much ash does this fuel release, yeah? And it was determined about 2 grams were kept in a porcelain crucible, transferred, preheated Marfo furnace again at 600 for 1 hour. Actually, this was, yeah, then it was also calculated. That was calculation of ash. Then next. Thank you. Another parameter which was determined was the calorific value, which is the amount of heat liberated by a complete combustion of fuel, okay? So this was also determined and using an oxygen pump calorimeter. So it's also another equipment. Yeah, please let's move on now. That's about methodology, results. Okay, the result here, you have table 1, will show that most of the materials which, thank you, available, you can see polythene, cloth were the most prevalent, but we had paper and organic waste. You can see which is quite high in all areas, about 30 and the like. So organic, then polythene and clothing. This table just shows the sum of what was found in the area. Next. Yes. So in figure 1, it shows the moisture content of the organic char, which was used. Of course, there were about 6. There were 6 samples that were processed. The sawdust, you had charcoal dust, we had dry grass, we had also organic matter, then organic peels, potato peels. So from the result, it shows that the char, thank you. Yeah, so from this table, you can see the moisture loss. The highest moisture loss actually was from sawdust. Yeah, sawdust, and also the organic peel, the last one, which was pretty high. But there are those which did not have much moisture content. Like the charcoal, yes, did not have much moisture content, but most of the moisture content was from the organic, dry organic peels, dry, the sawdust, and grass. Yes, next. In terms of the volatile, which is in figure 2, the composition ranged between 27 to 80% per weight. And the least volatile matter content was obtained from organic matter, but the highest was from the sawdust. In the next slide, we'll show that. Yes, yeah. So you can see the sawdust and the dry peels when showing the ones with the highest volatile matter. Next. Thank you. Next slide. Ash. The quantity, the amount of ash released also was a measure. And the ash content also ranged between 0.6 to around 48%. And the highest ash was also obtained from the organic matter, while the lowest was from the peels which were made from sawdust, not peels, but from sawdust, okay? And you could see there was actually a great significant differences when you use from one where ANOVA was exhibited between sawdust, organic peels. Next slide. Yeah, this is what I'm talking about. Yeah, determination of the ash bulky density. Okay, so you can see from the dry grass, yes, and also the sawdust. Next, for calorific values, which were also determined from these samples, the organic peels yielded the highest calorific value, which was about 7.5 kilojoules per kilogram, followed by organic peels. Okay, so to say that the organic peel.
Yeah, but if you can summarize now, give us your conclusions,
thank you.
Please.
So when you compare these samples, organic, Okay, so the chemical analysis now, you can say that the organic matter exhibited the highest fixed, carbon content, yes, which was best for prolonged ignition, because the amount of, from these parameters, from the chemical analysis, it was really all to determine how much carbon content is available for combustion. Otherwise, this is actually very much similar findings were found from Carif 16 and UNEP 15. Next, I think that is it. Next. Yeah, so this is actually next, following, next. Yes, so this is the, please, before, thank you. Just this last slide, second last slide. Thank you. So this, you can see this is organic material, and you can see the char after carbonation. So this is what would be used to use fuel. Thank you so much. Thank you so much.
Thank you, Nyambati. I'm sure you've you've raised a number of issues that I'm sure the audience would like to discuss. We will have some 2 minutes discussion, audience. Please, if we can have feedback from the audience, please. Please raise up your yellow hand. We can be able to see you, and we request you to be able to make your feedback. Now, very interesting discussion. Nyambati, while our audience is thinking or reflecting on some of the questions they want to raise, now, how many tons of organic matter do you think we can be able to recycle, given what you handled into useful energy?
Indeed. Thank you, Prof. It will be tons and tons. And but what I realized is maybe the work can be much, much easier if there was sorting from the source. Because I've seen in other studies where they are really not used necessarily for briquette, but for other energy, there is separation so that the organic is separated very early from the source, from the homes, from the households, from the industry. Then it can actually be used. Some developed nations use it to supply even electricity, to supply even biofuel. But for briquettes, for sure, it's on a very small scale. So when I say it's more from a very small scale, but it's doable. Thank you.
Thank you so much, Nyambati. If there are any questions, you can write them on the chat. And I'm sure, Nyambati, you would like to respond to some of those issues that you raised.
I'll be waiting. Asante
Thank
sana.
you very much. Thank you very much, Nyambati. Yeah. Now, we'll want to ask the next presenter, and that is going to be Dottie. I hope, Dottie, you're now logged in, huh?
Yes.
Yes, thank you. We lost you some times back. Probably maybe there was a technical issue.
Yeah, but now I think it's clear. Is it
very good? You are on slide mode. We'll give you 10 minutes to be able to present your work. Kindly keep time so that we have time to discuss your work. Okay. Thank you.
Welcome to my presentation. The title is about optimization of selected pyrolysis parameters in pyroligneous acid production rate and quality from acacia twigs. I am Bake Doti, and the following are my co-authors. That's Professor Nyanga, Dr. Samuel Nyakach, Dr. Jane, and Dr. Oscar Ingasia. Coming to the introduction, biomass, which we all know is a renewable source of energy and it's a decomposable organic matter, can be easily converted to pyroligneous acid through pyrolysis process. This pyroligneous acid is a condensate which is being produced during carbonization process, and it is being used as a biofertilizer or as a biopesticide. And pyrolysis is the same as carbonization, where biomass material is being thermally decomposed in absence of oxygen. And production of these pyroligneous acids depend on several pyrolysis parameters as stated by Kiza et al. That include feedstock moisture content, pyrolysis residence time, among other factors. And the title was about optimization, and this optimization is usually a technique that is being used to determine the optimal operating condition.
If you can reduce your speed, the audience is saying you're too fast.
Therefore, this optimization.
I wanted to raise my hand, but that was good. That was good.
So therefore, optimization.
I wanted I will
Can I continue?
present that you did a good job. No, we now need to do more and more. Please.
Yeah, Doti, please go ahead. Go ahead, Doti.
Therefore, optimization, which is a technique that can be used to determine the optimal operating condition of any system by either maximizing or minimizing, depending on the objective of the research. Therefore, this brings us to the broad objective of the research, which is to determine the optimal pyrolysis condition that can result to highest production rate and quality. Coming to the statement of the problem, the first statement of the problem here is that we have an increase in human population. An increase in human population means that the demand for food is high. And when the demand of food is high, farmers tend to use chemical fertilizers and pesticides to meet this demand. And when they use these chemical fertilizers and pesticides, it can result to air, soil, and water pollution. And then there is another point where there is an increase in agroforestry materials as reported by Liu et al. 2019. And these agroforestry materials, including the acacia twigs, managing this waste has become a very huge problem. And then the third point is that there is a pyrolysis system efficiency, which is very less, and that by considering the current technique that is being used. And justifying this statement of the problem, the first point, which was about the increase in human population, there is need for production of biopesticide and fertilizers so that farmers can completely meet the demand of the ever-increasing population without harming the environment. And then there is need for effective pyrolysis systems so as we can manage these agroforestry materials properly in order to produce either biochar, charcoal, or even pyroligneous acid. And then to increase the efficiency of this pyrolysis system, we need to have optimization. And once we optimize any condition, the pyrolysis system will have highest efficiency and the time will be offset. Therefore, coming to the materials and methods, this is the pyrolysis system that was designed and developed for the research. So at first section, we have the carbonization kiln. This is where we fed in our material, and that is acacia twigs. And the selected pyrolysis parameters that we are talking about here includes feedstock moisture content, pyrolysis residence time, and chimney inclination angle. The feedstock moisture content was varied from 20, 15, and 10%. And then the pyrolysis residence time was varied from 90, 135, and 180 minutes. And the chimney inclination angle was varied from 30 degrees, 45 to 60 degrees. And in this carbonization kiln is where we fed the acacia twigs. That's the kiln can handle about 100 kg of the feedstock material. And then after carbonizing, a smoke is being usually released into the atmosphere. Now this smoke is now what is being passed through a cooling tower where water is being used to cool this smoke that comes out of the carbonization process. And now after condensing, this smoke is now what we obtain, a pyroligneous acid down here. The smoke that comes out of the carbonization process, instead of releasing it into the atmosphere, we condense it so as we can produce pyroligneous acid, which can be used as a biofertilizer or as a biopesticide. Then there's a cooling water reservoir here where it is being used to supply cold water into the pyrolysis, into the cooling tower. Then to the optimization process. In order to optimize, a technique that is being used, that is being called response surface methodology, was being used for optimization. And under this technique, a box-Benheken design was being preferred since it can handle 3 variables. As you can see in the table below, there is a feedstock moisture content where the symbol was given as X1 and it was varied between 10, 15, and 20. Pyrolysis residence time was given a symbol X2. Chimney inclination angle was given an X3. From the data obtained, the equation that should research come up with is under this, where Y is the yield or any term that we are going to determine, and these others are the coefficient, where X1, X2, and X3 are the varied parameters. Coming to the result and discussion, at first we look at the effect of feedstock moisture content, pyrolysis residence time, and chimney inclination angle on pyroligneous acid production rate. These 3 factors are what was being varied. As you can see from the first graph, as feedstock moisture content increased, the pyroligneous acid production rate also increased before it starts reducing. And this result agrees with the one obtained by Oromai and Diba 2013. And the result and the reason why there's an increase in the yield is due to the moisture content that is being found in the feedstock material, but it starts reducing as those moisture content turns into a tar instead of pyroligneous acid. And then in the next graph, we have an effect of pyrolysis residence time on production rate of this pyroligneous acid. As you can see, for each chimney inclination angle varied, as pyrolysis residence time increased, the pyroligneous acid production rate also now starts decreasing. The reason why it starts decreasing is due to increase of uncondensed gas, the gas that cannot be condensed into pyroligneous acid. And then as you increase also the pyrolysis residence time, the amount of tar that is being produced also increases. And the result agrees with what Kiza et al. 2019 and Lu et al. 2019 obtained. And then for the chimney inclination angle, as it can be observed, as chimney inclination angle increases, the production rate now starts reducing. The reason why it starts reducing is due to an increase in the pyrolysis smoke. If there is an increase in pyrolysis smoke, the condenser or the heat exchanger in the system will not have enough time to condense this smoke, but rather the smoke now will just go into the atmosphere. The smoke speed was being determined using an anemometer, and at 30 degrees, the speed was 0.45, at 45, 0.58, and at 60, 0.72 meter per second. The data obtained was analyzed using ANOVA, and as can be seen, all the varied parameters has an influence or a significant effect on the production rate of the pyroligneous acid, since it had p-values less than 0.05. Then to the quality now. The density of the material, the quality that was being determined are the density and the pH. The density of the material remained constant, and the result agrees with the one obtained by Lu et al. 2019 and Lu et al. 2018. But pH tends to reduce with an increase in pyrolysis residence time. Therefore, as the data after it was being analyzed, only pyrolysis residence time had a significant influence on the pH. That's having a P value of 0.00, less than 0.05. But coming to the density, no varied parameters had significant influence on the density of the material. In optimization now, the following equations were obtained for all the varied parameters. So those are, for looking at the production rate, these are the equation which was being obtained: X1 representing feedstock moisture content, X2 pyrolysis residence time, and X3 chimney inclination angle, and others are quadratic terms and the interaction terms. For density, this is the equation, and for pH, this is now the equation. These three equations were being optimized, since our title is about optimization. In optimizing the production rate, the optimal condition was that to maximize this equation. That's now how we optimize. And for density, it was also maximized, but for pH, it was minimized. The three equations were combined, and the condition that will obtain the optimal condition, or the optimal conditions, are as follows. For feedstock moisture content at 20%, pyrolysis time at 137.27 minutes, and chimney inclination of 60 degrees, giving you a highest production rate of 0.19 per minute, and density of 1.03, and pH of 3.01. This is the pyroligneous acid that was being obtained, and then the pH, that's the optimal condition, was for 3.01 and 1.03. The pH was within the range as stipulated by the Parat 2018 and Lu et al. 2019, since the pH will be between 2 to 4 and density 1.01 to 1.05. Coming to conclusion and recommendation, conclusively, all the varied parameters, that's feedstock moisture content, pyrolysis time, and chimney inclination angle, had significant influence on pyroligneous acid production rate. But coming to its pH, only pyrolysis residence time had a significant influence, but no selected pyrolysis parameters had significant influence on the density of the material. And then for optimization, the response surface methodology technique that was used was very successful in optimization, since it had an efficiency of 96.63%. And in recommendation, as we have seen, increase in chimney inclination angle result to reduction in production. Therefore, someone might say that as we reduce the chimney inclination angle, we will obtain highest yield, but that might not be the case, since at 0 degrees chimney inclination angle, the system will be choked and no carbonization or pyrolysis will take place. Therefore, there is need to determine the minimum chimney inclination angle beyond which pyrolysis will not take place, and you obtain the highest production rate. And then there is an heat exchanger that is being used for condensing this smoke into pyroligneous acid, and the effect of this heat exchanger on the emission of gases into the atmosphere needs to be determined. Therefore, this system that's being designed is an innovation, and these research findings usually can enhance resilience in this changing environment, and that's now the theme of our conference. Acknowledgements. First acknowledgement goes to CESAM, that's Center of Excellence Sustainable Agriculture Business Management, for financing the research, and Kenya Climate Smart Agriculture Project, that's KCSAP, Bioenergy Researchers for Egerton University. These are some of the references touching on optimization, pyroligneous acid, and other factors. Thank you.
Yeah, thank you so much. Thank you so much, Doti. A very, very interesting piece of study. Perhaps my first question would be, what was the criteria for the selection of the acacia twigs? And perhaps if you're aware, which acacia species was used in this particular study? And number two, how were the optimization parameters actually selected? Was there a specific criteria for doing that? the audience is welcome to be able to interact with our presenter, Doti. Thank you so much, Doti.
All right, thank you. So the first question about the species of the
Doti,
acacia.
you can respond to that, and I'm sure there will be many others that will be raised by the audience.
All right.
You've saved us quite some time, and sure we can be able to interact on your research.
For the first question, that's about the types of acacia twigs that was being used. For my case, the acacia that we used was just from around Egerton University, even though we didn't determine specifically which type.
Doti, did you hear me?
Yeah.
Doti?
Are you hearing? Am I audible?
Yes, Doti, you are audible.
Doti, are
Yes,
you with us in the room? Huh?
Yes.
Yeah, he is.
But I'm answering. Prof?
Doti, can you hear us?
Yes, I can hear you, and I'm answering. Is there anyone else who is listening to me?
Maybe we can write questions on the chat.
No, we can hear Doti.
He'll be able to see them so that he can be able to respond to those issues. Maybe Doti is probably having a network problem. Yeah. Please, audience, go ahead and put questions, need for comments that you may want to be clarified on the chat. Like that. Next thing. Nalienya, if you're logged in, we'd like you to quickly go ahead and share your work. Nalienya, please. Nalienya.
Thank you.
Thank you, Nalienya. You can share your slides on slide mode. Please go ahead, Nalienya, without much ado. Thank you. 10 minutes.
Thank you very much.
We'll be able to have 2 minutes for discussion.
Thank you very much. I'm going to share the results from the investigation that we did on mitigating the formation of hexavalent chromium.
Nalienya, we can't hear you.
Are you getting me? You're getting me?
Yes.
Okay. I'm going to share the findings that we got from investigating the mitigation of the formation of hexavalent chromium in leather using aloe barbadensis mila, or in short, aloe vera, mixed with the carrageenan in the same ratio. I'm Dr. Nalienya from the Department of Physics. Now, we know that chromium-3 salts account.
Nalienya, if you can hear me, we can't hear you.
I'm hearing you.
I can hear Dr. Nalienya very well, Prof. Maybe you have a problem with your system.
I equally can hear him very well.
Yeah.
So what do I do? Hello, Prof. Prof, you're getting me?
Nalianya, are you able to hear us?
Yes, I'm hearing all of you.
We can't hear you, Nalianya.
I don't know.
I can hear Dr. Nalianya very, very well. My name is Wegulo. You must be having a problem with your system, Prof.
Yes. I can also hear very well, Prof.
So, do I proceed?
Maybe just find out how many people can hear you, Daktari. Then perhaps we can assist Professor Maranga.
I proceed. Eh?
No, I'm not in charge. I'm just saying find out how many people can hear you. Because I don't have any problem. I hear you very clearly indeed.
Chair, we can hear the presenter so clearly.
Nalianya, can you hear us?
Yes, I'm hearing you.
You can, eh?
Yes.
But we can't hear you.
Other members are saying they're getting me clearly.
Yes, I can hear the presenter myself.
Okay.
We
can also hear.
Yes.
Oh, okay, there we are. Okay. Nalianya, you go ahead now.
Oh, thank you. Now, we understand globally that chromium tanning accounts for more than 90% because of its effectiveness. And although we use chromium-3 salts to do the tanning, most of the environmental factors are capable to oxidize chromium-3 to chromium-6, which is highly toxic to the environment and also to human health. It's actually highlighted as a carcinogenic chemical. And this has led to the it has led to the high rejection rate of the chromium tanned leather. Aloe vera has been researched and found to contain glutathione peroxidase, superoxide dismutase enzymes, and phenolic compounds such as aloin and aloyamidine. And these phenolic components, they possess scavenging and antioxidant activities when it comes to reducing power. Aloe barbadensis also has been shown to improve the softness, the cooling effect, and the antimicrobial, and the bacterial, and antiviral, and antifungal effects in leather. On the other hand, carrageenan, which is a seaweed hydrocolloid, has been found to enhance the penetration of this aloe gel into the leather, since their molecules are have negative charge, whereas our collagen, which is now leather, contains the positive ions. So the molecules have the ability to suspend the alloy particles to maintain relatively better distribution of the particles within the leather matrix. It is on this basis that we did a study to investigate if alloy mixed with the carrageenan powder can inhibit the formation of chromium-6 in chrome post-tanned leather using a UV visible light spectrophotometer according to the standard procedure 17075. So leather samples were treated with a gel, were exposed to photoaging and accelerated thermoaging condition prior to determination of the chromium-6 inside the leather. So that is how we prepared our alloy miller, mixing it with the carrageenan, and we incorporated into our leathers. Sampling and conditioning was done according to ISO 2419 of 2012 and ISO 2418 of 2005. These are standard procedures of doing sampling, location, and also conditioning. Then the samples were aged in a thermal chamber at 80 degrees Celsius for 24 hours and UV cabinet with a wavelength of 254 nanometers for 132 hours. This is a condition to mimic most of the applications of leather application, and also they induce the thermodegradation and the photodegradation that leads to the formation of chromium-6. Grinding and extraction of chromium-6 from our samples was done following religiously the procedure ISO 17075. Then the UV spectrophotometry was done at 540 nanometers using Genway 7315 UV VC spectrophotometer at the chemistry department. And the analysis was done using chemical reagents of analytical grade. The absorption was measured using a UVC spectrophotometry at 540. And standard calibration was done as given, or as the procedure given in ISO 17075. Now, the calculation of chromium-6 inside our samples was done, and this is a procedure that is also well highlighted in our ISO standard procedure. And limit of quantification and detection were calculated from the two equations. Our standard calibration data is as follows. We have the absorbance for the blank and for different concentration from the stock, and we have that table. When we drew the graph, we can see that the graph closely obeys the linearity, which implies that our data agrees very well with the Beer-Lambert's law. And we also determined the limit of detection and the limit of quantification to be 0.28 and 0.0948 milligram per kilogram respectively. Now, when we did the absorbance of post-tanned crusts that have been aged at 132 hours UV plus 24 hours at 80 degrees Celsius, we have the samples that we have added our diphenyl carbazide and the ones without diphenyl carbazide. And we have those values. And we also did on the aged samples. And when we did on the aged samples, again, the absorbance of the tanned return dyed fat liquid is as shown in our table 2. We also calculated the recovery rate, and in all of them, the recovery rate was at an average of 98%, which actually indicates to us that there is no influence of matrix on our results, and hence the procedure conforms closely with the ISO standard. Now, we calculated the value of chromium-6 in both control and aged post-tanned crusts that have not been incorporated, our aloe vera and carrageenan. And for the non-aged samples, only returned posted 183 levels of chromium-6. The rest of them, the tanned, the dyed, and the fat liquid, there was no chromium-6 that was tested. That means that it was below the limit of detection. After aging, we find that all the samples had chromium-6 in them, with the returned returned leather having the highest levels of chromium-6, and then followed by the fat lacquered. A fact that we can attribute to most of the unbound chromium-3 that is found in returned, and in the fat lacquered, we can attribute it to the double bonds of the fats and the lipids inside the leather. So after aging, significant levels of chromium-6 were detected due to the thermal and photoaging that actually induces the chromium-6 through radical formation. Now, we did standard calibration when we had our samples now treated with our alloy and carrageenan, and that is our standard calibration data and the graph. And as we can see again, the linearity is 0.999. This means that our data obeys the Beer-Lambert's law. And we calculated the values of chromium-6 for the samples without alloy and with alloy, those that have been aged and those that have not been aged. And we can see that chromium-6 in crust processed with alloy Barbadensis Miller mixed with the carrageenan, both aged and unaged, were below detection level, implying that the hexavalent chromium in these samples were actually below our detection level, a limit of detection. For all the aging conditions that we conducted in this study, that is 132 hours in, at 254 nanometers, we can find that the effectiveness of our alloy is actually 100%. Therefore, the inhibition of our alloy and carrageenan against formation of chromium-6 was observed to be superior in our study. Now we did the absorbance of post-turned for the aged samples, and that is the data that we got, both with the alloy and without alloy, aged and unaged. And we can find out that the superiority of our antioxidant activity of our alloy can be attributed to the high contents of antioxidative components inside our alloys, such as polyphenols, indols, alkaloids, tetradecanoic acid, methyl, all those components which have been found to be in our alloy. Studies have already shown that the catechins that are in alloy possess the ability to reduce covalent modification of collagens induced by the reactive oxygen species. So the activity of alloy has already been measured to be in the range of 87 to 88% and 65.65% when you use alpha tocopherol. So the superior performance of our alloy can be related actually to the synergistic action of both our alloy and the carrageenan, which we can say that they boost each other's efficiency, and that's why we have 100% inhibition. And we can actually discuss the action using two mechanisms. The antioxidant components within our alloy may have played in two mechanisms to actually inhibit the formation of chromium-6 by delaying or preventing oxidation and stabilizing the deforming free radicals, or simply preventing oxidation by gelating metals. And of course, antioxidants have been known to prevent or interfere with oxidative reaction in collagens by chelating off or scavenging the free radicals, which are known, and donating free electrons. And of course, when we donate free electrons, we are going to reduce chromium-6 to chromium-3 back. And we can also talk of the antioxidant, which are so many in this plant, were able to hinder the absorption of UV radiations, which are actually necessary to achieve the photodegradation And through photodegradation, we have the oxygen reactive species, which actually undergo the chain reaction to bring about the chromium-3 being oxidized to chromium-6. So we can be able to say that actually they hinder the absorption, or they delay or prevent the oxidation. And in this case, we can talk of either they donate hydrogen, or they eat away the oxygen atom. And in this case, they delay or prevent the oxidation. We can also talk of in tanned samples that have not been aged. We already found that it has significant amount of hexavalent chromium. And of course, we can attribute this to the unbound chromium-3 salts that are so many inside returned samples. And that means that auto-oxidation alone is sufficient to actually oxidize this chromium-3 into chromium-6. And we can say that auto-oxidation may not have enough energy to deal with the bound chromium salts, but it has enough energy to deal with unbound chromium salts, which are many in returned samples. And we can find that the levels of chromium-6 in leather crusts processed with our mixture were below detection level.
Now, if you can summarize, Nalianya, if you can now summarize your work.
Oh, thank you. I'm actually through.
Okay. Okay, and then my first question is, what do you think is the significance of the contribution of this study?
We are having a leather industry being branded as one of the most hazardous industry because of the chemicals they release to the environment, and also the leather that we produce, especially in Kenya, which we cannot export to European Union because they want leather that has chromium-6 less than 3 milligrams per kilograms. And this has limited or has led to rejection of leather that has been tanned using chromium, because there is no way leather that has been tanned with chromium will have less than 3 milligrams per kilograms. So this will add to the mitigation measures that will lead to still using chromium, but attaining a leather that will have chromium-6 measuring less than 3. And this will increase actually the acceptance rate of our leathers in European Union and even other developed countries. And again, NEMA coming in, already the leather industry is operating as a black market because of the toxicity, because of the pollution. This will help the leather traders and manufacturers also to circumvent the strict regulations of leather manufacturing. Thank you.
Thank you so much, Nalianya. Comments and questions from the audience. Let's just have some 2-3 minutes interaction with Nalianya. I hope I pronounced it correctly. Nalianya, eh?
Yes, Nalianya.
Okay. Questions or comments? You can write some of the questions if you so wish on the chat. You can also raise your yellow hand so that we're able to see you and ask you to go ahead and make your feedback. Okay, Francis Wegulo, please, Prof, go ahead.
I like the question that you asked Dr. Nalianya, Prof, about the contribution of this study to matters industry and whatnot. I'm just listening in, but I'm interested to know if we, in terms of scale, if we have sufficient capacity to be able to handle our leather in sufficient quantity so that we can meet not only the standards required in the countries to which we export, but also in terms of quality. So can we do enough in terms of what Dr. Nalianya is explaining, with regard to the materials that we have in matters aloe vera or whatever, to meet not only the quality, but also the quantity required of our leather in those countries where we export.
Over to you, Dr. Nalianya.
Thank you. Now, of course, we know that leather industry is one of the, if I can call it, an environmental friendly industry, because it utilizes something that we may have thrown away. This is the skin and hides, and we convert them into useful material. And every time you eat meat, that means that there is a leather somewhere that has been left. So we have enough leather in the country, and even more than that. But the problem is the strict and the stringent regulations that have been attached to this industry that have made this industry to operate as a black market sector. And these stringent, regulations, they emanate from, one of them is our NEMA. The other one is now when we try to export. And you'll find that only Indians and some few Chinese will come and take this leather at a very early and processed stage, and they buy very cheaply. Because if you process it to tanning, you're going to introduce the restriction that is now the chromium 6. So they only buy it very cheaply after it has been dried and it has been, it has been salted to preserve it for some time. But this is, again, because of the little that it yields, it's not an industry that people have, embraced. But the Indians and the Chinese take advantage of taking the unprocessed leather, and they go and process and sell very expensively. Otherwise, this is an industry that is untapped. Although the government has been, earmarking it every now and then as untapped potential, but very little has been done, and it's because of some of these regulations.
Okay, thank you for that answer, Dr. Nalianya. I would have asked another question, but perhaps we can do this another day. Thank you.
Thank you, Professor Ugulo. Thank you so much, Dr. Nalianya, for a very exciting study. We hope, we can scale up this particular useful intervention so that this can be able to assist this country and be able to deal with some of these, environmental materials that harm our environment. Thank you so much again.
Thank you.
Okay. We want to get to our next presenter, and I'm not sure whether Bidai is in. Bidai, are you in now? Oh, you've already presented. Okay, thank you. Okay, Bidai is already presented. Bidai, have you presented, Bidai? I hope not. If you are in the room, please let us know. Bidai, and then JP Ouma. Not yet. Now, EW Nyokabi, if you are in the room, please, we'd wish to listen to your presentation. EW Nyokabi, are you in the room? Then Wycliffe Okwara.
It's Wilberforce.
Yeah, thank you. Please go ahead and share your slides with us.
I think the presenter should unshare the screen first before I do that.
Okay, Nalianya, please stop sharing. Okay, thank you. Wilberforce, if you can stick to 10 minutes, and then we have 2 or 3 minutes for discussion of your work.
Okay, thank you. Can you hear me?
Yeah, sure, pretty well.
Okay, thank you. I'm Wilberforce Okwara, and was carrying out the work on effect of process techniques on 3 feedstock mix on briquette performance properties. And this work I was carrying alongside Professor Daudi Nyanga and Dr. Engineer Kabok, together with Professor Francis Wegulo. Next, please. Under the introduction, actually energy is one of the components of sustained development in any country. And if poverty is to be eradicated, then you have to consider energy. But then availability of this energy at domestic level is a challenge across the world, and especially in Africa, where deforestation and high cost of fossil fuels are experienced, like just the current situation in the market right now. Significant quantities of biomass are available for conversion. This biomass can be municipal, agricultural, or even industrial. This contributed to the broad objective of this paper, which was the effect of process techniques on 3 feedstock mix on briquette performance properties. Next, please. Statement of the problem. Actually, high cost of LPG or liquid petroleum gas, electricity, and kerosene has led to deforestation. And through this deforestation, we are doing harm to the environment. And according just to the United Nations Food and Agricultural Organization statistics in 2019, over 9 billion metric tons of agricultural residues were produced, and the same year, over 9 billion of forestry waste were recovered. That means we need to know where to take those waste. Then we have different briquetting techniques in the market, but then to choose among the existing technique is becoming a problem to the farmers. Next, please. Justification. Environmental and health hazard associated with disposal of this waste. We are talking about over 9 billion, and that's just agricultural residue. We cannot say that we leave over 9 billion to decay in the farm. We'll be lying to ourselves. And we cannot burn over 9 billion in the atmosphere. So environmental and health hazard associated with this disposal of this waste is a challenge. And again, burning of this waste, 32% annual deaths occur from burning of this waste. But then the interesting part is, if we were to blend these residues and come up with briquettes, we'll have solved the equation of environmental, and then we shall have energy. But through that, SDG number 7 will be realized, which is all about reliable, affordable, and clean energy. Next, please. For us to carbonize or come up with briquettes, we had to do carbonization, and this is just the experimental kiln that was used. We were carbonizing rice husk, maize cobs, and sugarcane bagasse in mixed ratios, and we used 9 mixed ratios. The mixed ratios were developed using Taguchi technique. Next. Briquetting techniques that we used, actually used the screw press that produce cylinder-like briquettes, and then we are using drum agglomerator that formed fireballs. Next. Now, results and discussion. Actually, might be talking about the screw press, which is a pressurized technique, drum agglomerator, which is non-pressurized. But we are forgetting that we can also make briquettes using hand. And we do not know if maybe the handmade briquettes are better than the one used with technology. That's why we had to carry out using hand briquetting. So as you can see from this table, we were looking at ignition time, that's IT, then time to boil. When we talk about ignition time, I'm talking about the average time taken to light briquettes, then time to boil, or burning time is the average time taken for briquettes to bring water to boiling point. Then you have BR, or burning rate. Burning rate is the rate at which certain mass of fuel is combusted in air. Then you have specific fuel consumption, which is amount of solid fuel used in achieving a defined task. And then you had power output, which is the available amount of energy released from a fuel in a given time. So when we were looking at ignition time, as you can see, screw press, we got average of 4, then drum 3, and briquetting 3. But then for us to choose the best fuel, that fuel should have less ignition time. And thus, you can see the range is not that bad, 3 to 4. Then you have the boiling time, or time to boil, which range from 11 to 14. Then you have the burning rate, which range from 0.8 to 1.3. Then specific fuel consumption, you can see 0.11 to 0.15, and then power output range from 0.75 to 1.8. Best fuel should have a high power output, low specific fuel consumption, very low burning rate, very low time to boil, and very low ignition time. Next. Next. Okay, here, ignition time. Now, we have said that we were checking the effect of the process technique in regard to 3 feedstock. Comparing to other studies, actually it was found out that ignition time increased with an increase in feedstock and also with pressure. As we have seen from the table, as from hand technique to screw press, power output increased and specific fuel consumption decreased. And this value compares well with 3 minutes to 3 to 4 minutes reported by Dideng et al. 2015 and Agrian et al. 2021. However, now, when we were checking the time to boil, number of feedstock used did not affect time to boil. If you used 1 feedstock, or even if you used mixed ratio, actually that did not affect. But technique used had significant effect.
We lost you temporarily.
Okay, next. Okay, here we can see the specific fuel consumption, and here we are taking the effect of briquetting technique on specific fuel consumption. You can see from cold start, hot start, and simmering phase, the blue. This blue represents screw press. It's decreasing, which should be the trend in any fuel. And This value decreases with an increase in number of feedstock, and as we apply pressure, you can see as we apply pressure, the value decreases. The last one here is power output, and power output was not affected by the number of feedstock. Whether you used one sample, whether you used mixed ratio, there was no effect. However, technique used to produce this briquette was a factor depending on the applied pressure. Next. Conclusion and recommendation. Under conclusion, briquetting technique and number of feedstocks significantly influence performance characteristic of briquettes, and therefore we should know how many feedstock in terms of number are we required to mix for us to come up with a briquette, and which technique, is it pressurized or non-pressurized, if you have to come up with briquettes that will meet the market. Under recommendation, actually might be carrying out tests on briquettes, but we don't know if you are doing harm to the environment than even charcoal or what, and that's why emission tests or effect of burning briquettes should be compared to charcoal and fossil fuels. Next. Acknowledgement. Actually, I want to acknowledge Egerton University through Center of Excellence in Sustainable Agriculture and Agribusiness Management, CESA, and the Climate Smart Agriculture Project, CASA, for helping us come up with this study. These are some of the references that were used in this. Next. Thank you.
Thank you so much, Wilberforce, for this study. Very interesting indeed. If you were to package a message for the common person out there, yes. Now what will you tell them about the value of this study? We will also want to receive reactions from the audience, please. We have a few minutes. We can be able to share our feedbacks with the presenters, if you don't mind. Prof. Rose Thiambo, as Wilberforce reflects on the question we've asked him, yes. Professor Thiambo, please be ready to be able to raise your question as well. Wilberforce, if you're hearing us, please go ahead.
Yes, I got you, Prof. Loud and clear. You are asking about the relevance of this study to the common wananchi.
Yeah, the common wananchi. They need a simple message that they can understand from the value of this study, yeah?
Yes.
Okay.
Actually, what I can say, Prof, is from agriculture, after harvesting, a lot of waste is left in the farm. So to them, a message is this waste can be used just to make fuel, not just to be left in the field to rot or even burnt in the atmosphere. So message is clear, we can use waste to make energy.
Thank you. You're saying we can recycle waste into useful products, huh?
Yes, Prof.
Thank you. Professor Thiambo?
Prof.
Thank you, Chair.
Oh, okay.
Sorry.
Yeah, then Professor, we will after Professor Thiambo.
Yeah,
sure.
Thank you, Chair. I really wanted to ask my question before you responded to yours, because we now know that use of briquettes is becoming very lucrative, and many people are into this. It's not my area, but I was looking at the figure 1 that he presented, and I was wondering, what would you tell somebody who is trying to make briquettes by hand, considering that you are telling us we can use waste? Are those figures from, you know, the areas you are pointing out that are important to know the best briquettes? Would you encourage somebody to use a hand to make that, or it is actually a useless effort? Because most of us cannot afford the machines.
Wilberforce, please respond.
Yes, yes. Thank
Yeah,
you,
figure
Prof.
one.
Yes, is it figure one or table one, Prof?
Table one, sorry.
Will they, please, let me just share, please.
Figure one. Figure one, huh? Well, I think step one. Okay, that's good enough.
This, here.
Yes, that one.
Yes. So I didn't get you clear, Prof, please.
My question is,
Yes.
from these parameters, I don't know, burning rate, you know, that is not my area.
Yes.
But I can see power output and all those things. How
Yes.
would you advise somebody from your research, somebody
Yes.
who is making hand briquetting?
Yes.
Is it a viable project, or they have to use those screw press and the agglomerator?
Okay,
How
okay.
Yes.
If I was to advise Prof, actually, if you are to do hand briquetting, you will be doing more harm, because the power output, the power that will be using to, the power that will get from the waste is more or less than what even charcoal gives us. Charcoal gives us around 1.2 kilowatts. And you can see if we briquette using hand, we are getting power less than what charcoal gives us. So I would recommend that we don't do hand briquetting. We only carried hand briquetting to see if maybe we would be going for this machine, and yet we have a very cheap technology that we can use, but we found out that it was not the best.
Thank you.
Thank you.
Okay, thank you again, Wilberforce. Professor Wegulo.
Thank you, Chair, and thank you, Wilberforce, for bringing this information to us. I just wanted to add to the question that you asked Wilberforce about the message that would be appropriate, you know, for sharing with people out there, you know, in the rural areas and even those in urban areas with respect to the relevance of this kind of study. And I wanted to say that there's plenty of, I was part and parcel of this project, by the way. And so I know a little bit more than perhaps we can share. And I was just adding that there's a lot of waste, crop waste, that can easily be converted into very useful material for helping our households to increase and improve on their energy needs. I don't know if, am I being heard?
Sure, we hear
Oh,
you.
fine.
Yeah.
And I think Wilberforce talked about crop waste, and perhaps giving examples, for instance, maize cobs, which people use. Sometimes they throw away, but increasingly because of scarcity of energy, I think that people are now beginning to ban this. Interestingly, if you convert maize cobs into let's say briquettes, you get so much value out of it. So, you know, through very simple processing, part of the processing that Wilberforce was talking about. A very simple technology, which I think Wilberforce didn't include, is the improved earth kiln. And the earth kiln is not costly, is affordable. And yet, if you use it to convert maize cobs into biochar and then eventually into briquette, it brings a lot of value in terms of those parameters that Wilberforce was talking about. And so the message that I think, enhanced message, I would put it, that comes from this research is that there are technologies that are simple, some of which could be improvement upon what people have been doing, in terms of increasing value and increasing their diversity of energy options in many of our rural areas. We are talking of crop waste. We are talking about, in particular, about maize cobs. We are talking about rice husks. We are talking about increasing even twigs. I was surprised that, you know, the traditional view of charcoal, for instance, is that you need very big trees which you split and which you burn so that you can get charcoal. The modern technologies that Wilberforce is talking about, you don't need big trees. You need actually branches, small twigs as feedstock. And out of that, you can get very useful energy. The matenge, which has been a nuisance in a number of areas like Marigat, where we did quite a bit of work. You know, the idea with matenge is that you don't cut the tree. You use the small branches, which you cut in small pieces and which you put into these kilns. And then after 2 hours or so, depending on the moisture content, you have your charcoal. And another advantage, of course, is that once you have these kilns, which are suitably constructed to suit the conditions and cost implications of most communities in the rural areas, once you do that, you split add the things and pack them into the kiln and go doing other things. After 2 hours or 3 hours, you get back and you're able to remove your charcoal. Properly done.
Thank you.
And ready.
Thank you so much, Prof. The message is much clearer now. Thank you, Prof. The message is much clearer.
Yes, thank you. Sorry about taking that too long.
No, that's okay, Prof. Thank you.
Thank you.
Thank you so much again. Wycliffe, you have an issue, a question that you want to raise. Obuola.
Prof. Thank you, Prof.
Yes, Wycliffe, go ahead. Yeah.
I have one question. Can you hear me, Prof?
Sure, pretty well. Huh?
Yes, I just want to, first of all, I would like to thank Wilberforce for good work.
Thank you.
But I have one question.
Yes.
I understand that in briquette making, use of binders is very key.
Yes.
So did he use binders before producing these briquettes, and what effect did it have in the findings? Thank you.
You are right. In briquetting, we must use binders, but it's not always that binder is needed. Binder is only used when using the low pressure technique, like when you are hand briquetting, we used binder, and when you are using the drum agglomerator, we used binder. But then the effect of binder on the briquette will come in the next objective, which, if you allowed me, I would again present to you. It's ready, I can do it, but because of time, although binder has an effect, that one for sure, I will leave a message with you that binder has an effect.
Thank you.
Thank you so much, Wilberforce, for your contribution. We can see quite informative presentation, and those recommendations. The screw pressing machines compact the briquettes as compared to hand. Again, a response to Professor Rose. Now, Dr. James Mushori, you have a question.
Yeah, thank you, Chair. Not a question, but just to echo what my colleagues have said to the presenter. Egerton University is known for practical solutions to issues affecting the society, and therefore it embraces what we call appropriate technology. So I would say to the student, be careful, especially when you're coming up with the technology, consider factors such as, is it affordable to the local mwananchi? That is to accommodate citizens. So check on what it is about appropriate technology and incorporate those ideas. It will be very useful.
Yeah, thank you so much, Dr. Shuri. Now, any other feedbacks relative to the other presentations that we have listened to? I'm sure we didn't have a lot of time to discuss some of those, but if it's something you have remembered and it's an issue that you want to raise or a comment you want to make, you're free. We can share some 5 or 7 minutes to be able to interact on the already made presentations. And you're also free to be able to write on the chat if you so wish.
Hello, Prof.
Yes, please.
This Wilberforce. I don't know if Grace Nyambati was making a statement or was a question when she said the screw pressing machine compacted the briquette as compared to hand. I don't know if it was a question or a statement.
Nyambati, if you're in the room, please, you can go ahead and respond.
Thank you, Prof. I'm in the room. Actually, it's an area of a lot of interest in. Thank you.
Please go ahead.
That.
Yeah.
Yes, it was just a comment.
Okay.
Actually, when you use the presser, the briquette becomes firmer, so it will take even much longer than when you are using these other methods. That's all I was just contributing. Thank you.
Okay, thank you.
Yeah, thank you. Thank you for those responses. Now, somebody saying, I noted the word briquette or briquette is a diminutive form of brick or brick, in the same way cigarette is to cigar, or kitchen to kitchenette, and so on and so forth. Perhaps we can learn from that particular feedback. For me, that is quite exciting. I know that many times we've used
our chairman of council.
This is from the chairman of council. Eh? I know that he's a very fine man when it comes to the English language. But I know it's a lot of slang and the rest of it that has entered into a vocabulary in terms of the way we communicate. But I hope that this is okay. Any other responses? Now, Gitonga, if you're in the room, you can also articulate what you have given to us as a poster. Please go ahead if you're in the room. Yeah?
Okay.
Okay.
Good afternoon, everyone.
Good afternoon.
Okay. My name is Pamela Gitonga, and that is my poster. I was working on. I was checking on the ameliorative effects of natural products on serum biochemistry and histopathological changes of broiler-fed aflatoxin contaminated feeds. And my supervisors were Professor Titoek, Professor Kingori, and Professor Obonyo. To start with, aflatoxin is one of the group of many mycotoxins that exist, and in poultry production or industry, we find that aflatoxins have been a great challenge because they contaminate the feeds and also the feed ingredients, like for example the soybean, the maize. So there is a need to reduce or to control, to mitigate this problem because when we consume these poultry products like meat from the poultry that have consumed aflatoxins, these toxins are carried over to our bodies. Therefore, this study was aimed at looking for these products that can reduce or control the effects, the negative effects of aflatoxin in the broilers that were fed aflatoxins. And in my case, the materials that the products that I used, I'm doing just a summary maybe because it's a poster. I used 2 products, which were banana peels and rice husk ash, which I compared to a commercial binder, which is available in the market. So in my experiment, I had 8 treatments whereby there were some positive controls, whereby there was aflatoxins and a diet without aflatoxin, and then there was also diet with maybe the binder, the commercial binder, and another one without with aflatoxin, but and a commercial binder. This was to help me to see whether the results that I'm going to get, are they due to the aflatoxin or this binder is having some other negative effects. And interesting, in the findings, we were able to see that one of the aflatoxin was able to bring some negative effects by increasing the enzyme ALT enzyme concentration, because it shows there was some negative. It's like the aflatoxin was causing some negative effects, stress to the enzyme, so that's why the enzyme levels were elevating. But the interesting result is that the rice husk ash was able to reduce the level of ALT enzyme. So this is a good thing to show that at least it was able to suppress the negative effects that aflatoxin would have had caused in these broilers. But the other parameter that we were looking at, the weights were not significantly affected, maybe because of the levels. Maybe if I used higher levels of aflatoxin, these would have come out very clearly. And the other interesting finding was in the liver, the pathological output. The diets that were containing aflatoxins, they showed some liver damage, but the ones that were supplemented with the rice husk, then the liver damage was reduced. So it was also a positive thing about these natural products. For the banana peels, it was they supported this research, and also animal science lab and mycotoxins laboratory for providing the space, conducive environment for me to carry out the research. Thank you.
Yeah, thank you so much, Pamela, for that very interesting study here. Now,
Yes.
aflatoxin remains a problem. It will continue to be a problem. But I think the way we're beginning to see how we can be able to manage it, I think is a good way forward.
Yes.
I'm sure you'll be more than inclined to be able to, even in the future, to commercialize some of these products that we're beginning to see that serve as good binders for aflatoxin. Thank you very much. Yeah, thank you so much. Now, it seems to me that our time is up, and we need to go back to the plenary so that we fill a poll there. For now, I think if Pamela, you can stop sharing what you have on the screen. Thank you so much. I want to thank all the participants. You've been very, very keen. I can see we've stabilized at around 30 or thereabouts, and that seems to me that this has been a very interesting, really, as it was, session. But before we leave for the plenary session, I can see Blessing maybe as a burning question. Blessing Adelabu.
So much. I'm Dr. Blessing Adelabu from Nigeria.
Karibu, thank you so much. Go ahead.
So I've been enjoying this. I joined the presentation so far, and especially this aflatoxin. I want to ask the presenter, are there any measures that we can put in place to reduce or prevent aflatoxin from our crops? Because we all know that these aflatoxins are being produced by microorganisms, especially fungi. So are there ways that we can use to prevent them so that they will not be able to contaminate and henceforth produce the aflatoxins? Thank you.
Thank you so much. Pamela, would you like to respond in a second?
Yes, I can.
Please go ahead.
Actually, there are crops that have been developed, and also there are treatments that we offer to the soil. But aflatoxin problem continues because it can attack at the crop level, but also when you harvest, you can harvest a good crop, but if you do not do good storage practices, the aflatoxin may come in there. Maybe you did some good practices, but when you're transporting, there are some. So the problem is we can have good crops. There are actually good crops, crop management skills that are there to prevent mycotoxins, but the problem continues from harvesting, storage, selling. So it continues even after harvesting the crops. That's why the challenge is there.
Yeah, thank you so much for that response, Pamela. And thank you so much, participants from all over the world that have really made this session very interesting indeed. We've shared quite a bit. Now, I'd like us now to be able to go to the plenary. At the bottom of your screen, you can see breakout rooms. Now, if you click that, then it will ask you for where you like to go to. Just a minute. Just simply leave the room, leave the breakout room, and then you get into the plenary, okay? But don't leave the meeting,